Welcome back to today's episode on 10.3. Today we're going to talk about the excretory system's importance with the other functions in the body, and some of its own very vital processes. We should remember that the kidneys are responsible with the reabsorption of water from the filtrate and creating a water-salt balance. I also mentioned in the first video that the kidneys and the circulatory system have a great relationship, and that the kidneys strongly control and regulate blood pressure and acidity or pH. Thirdly, I also mentioned in the past videos that the kidneys aid with the secretion and distribution of hormones. We'll cover each aiding function in depth. Part 1. Let's pick up where we left off with the reabsorption of water in the tubules and the collecting duct in the nephrons and the creation of the water-salt balance. We can recall whilst balancing the salt concentration, osmosis will follow because of the force generated called osmotic pressure. Osmotic pressure affects many cellular activities, especially the exchange of materials between cells and blood. Osmoreceptors located in the hypothalamus that detect the change in pressure help maintain homeostasis. This includes things such as hunger, thirst, blood pressure, body temperature, fluid balance, and salt balance. When we are dehydrated, blood plasma becomes too concentrated, triggering osmoreceptors in the hypothalamus to secrete antidiuretic hormone or ADH. Diuresis means increased excretion of urine. Since the anti prefix means against or opposed to, antidiuresis means decreased excretion of urine. This simply increases the permeability of the distal tube and the collecting duct, the last two parts of the tubules, hence absorbing more water into the bloodstream, diluting the blood. Now you can imagine that the complete opposite will happen if you are overhydrated or when your blood plasma is too dilute. To say it simply, ADH, which is the antidiuretic hormone, is released when you're dehydrated to keep the water in your body, and when you've had a lot of water, ADH is not released, so your body filters the excess water out. The condition diabetes insipidus is evident when the activity of the antidiuretic hormone, or ADH, is deficient. A person with this condition urinates excessively, around as much as 4 liters to 8 liters per day. Of course, this will result in intense thirst, but water is excreted more quickly than it is consumed. Synthetic ADH medication can be taken to control this. The ethanol content in alcohol and caffeinated drinks makes it diuretic, which I mentioned means that it increases the excretion of urine. It basically inhibits ADH and makes the distal tubule and collecting duct less permeable. Examples can include when you've had coffee, you may need some water after it, or having a lot of ice in your Coca-Cola may help to balance it. Ironically, this disproves the Coke commercial that says it quenches your thirst. We should also recall that kidneys regulate the salt to water balance in our blood. Sodium concentration, being the most abundant ion in our blood, can fluctuate based on both our diets and our consumption of diuretic drinks. In 10.1, renin is mentioned as an enzyme that is released to promote the secretion of aldosterone, which we know comes from the adrenal cortex. Aldosterone helps reabsorbing sodium back into the blood. But what about the water? The water follows passively through osmosis, therefore creating the salt-to-water balance. Renin is primarily released when the blood pressure is too low, affecting productive glomerular filtration, which we said last video needs a steady and strong blood pressure to filter the blood. Part 2. The normal pH of our blood is around 7.4, which allows enzymes in our blood to function properly. Many things can affect homeostasis and denature our enzymes, such as a diet with acidic foods or cellular respiration. 3 mechanisms that aid in maintaining homeostasis are the acid-base buffer system, respiration, and the function of the kidneys. Firstly, the acid-base buffer system shields the blood by taking up excess hydrogen or hydroxide ions that enter the blood. One of the key buffering reactions in the blood involves carbonic and bicarbonate ions. These reactions will only work temporarily if needed. Secondly, if hydrogen concentration becomes too high, the medulla oblongata signals the respiratory system to increase the breathing rate, which generates carbon dioxide much quicker and reduces the amount of hydrogen ions. Thirdly, only the kidneys can rid the body of acidic and basic substances, adjusting the pH. The kidneys are slower acting than the other two mechanisms, but they have a more powerful effect on the pH. The kidneys will reabsorb hydrogen and bicarbonate ions as needed to stabilize the pH of the blood. Ammonia, which is a byproduct of the breakdown of amino acids by the tubule cells, also plays an important part in the removal of hydrogen ions. Part 3. As we already clearly tell, the kidneys play a strong role in the releasing and distribution of hormones. Some of the main hormones include renin, which promotes the secretion of aldosterone, which is responsible for reabsorbing sodium from the filtrate. Erythropoietin is secreted to promote red blood cell production in the bone marrow, and parathyroid hormone is secreted to promote the secretion of calcitriol, which then promotes the absorption of calcium from the digestive tract. Part 4. Let's cover the issues that are associated with the kidneys. Clearly, the kidneys are arguably the most important organs in our body, aside from the brain and the heart. They are involved in many other systems, so this indicates that many things could possibly go wrong. Two common disorders are the urinary tract infection and kidney stones. The first could be cystitis, which involves the bladder, or urethritis, which involves the urethra. This is more common in females because the urethra is closer to the anal opening, meaning bacteria from the bowels can easily enter the urethra.
Symptoms include painful burning sensation during urination and need to urinate frequently even when there's no urine present, bloody or brown urine, tender upper abdomen or lower back, chills, fever, nausea, vomiting, kidney failure, and possibly even death.
Treatment could be as simple as taking antibiotics, drinking a lot of water, or simply just keeping good hygiene, aka wiping properly. Kidney stones are almost exactly what they sound like. They are stones or crystals that form from a buildup of excess calcium and could be caused from simply not drinking enough water. Sometimes these stones can pass on their own, but they could also be too big and very painful to pass. Medication can be taken to break down the crystals, but if they're too big, surgery involving ultrasonic shock waves must be done to break down the crystals or even remove them. A third disorder includes renal insufficiency, which means the nephrons are damaged, preventing the maintenance of homeostasis. Many things can cause renal insufficiency, including kidney infection, high blood pressure, diabetes, a blow to the lower back, food poisoning, or the blockage of the tubules. Even though this happens, the kidney can manage even if only a third of one kidney is working. Any more than that may require a transplant. Transplants aren't always the easiest resource to have access to, so in the meantime, the patient must be put on something called dialysis. Dialysis, simply put, is a procedure that removes waste and excess fluid from the blood when the kidney function is lost due to renal failure, basically functioning as an artificial temporary kidney. One of two types of dialysis can be done. Hemodialysis utilizes an artificial membrane and an external device that is connected to an artery and a vein in a person's arm. Peritoneal dialysis utilizes the lining of the intestines since they have the same absorption properties, called the peritoneum, as the dialysis membrane. As mentioned, dialysis is only temporary and eventually a kidney transplant is required. Unfortunately, in comparison to other developed countries, the rate of people donating is very low, at almost 14 people per million Canadians. On the flip side though, the success rate of kidney transplants is fairly high, at 98%. If the kidney is rejected by the body, it can no longer be useful to either the donor nor the recipient. New technologies are being developed to help prevent the rejection of donor kidneys. Part 5. To wrap up, we're going to talk about how to evaluate the function of the kidneys. We know that our kidneys are heavily involved with many other important systems in our body, and keeping track of the kidney's health is crucial to keeping tabs on the whole body. This observation has been made by physicians many years ago, resulting in something now known as urinalysis, beginning with something called the urine wheel. The color or the scent of a patient's urine could mean a variety of things. Now, physicians compare the urine of a sick patient to the average healthy adult to establish what procedures must be undertaken. Another important fact is that a urinalysis may help lead doctors to understand other bigger issues that a patient may have. Yes, once again, we know that the urine and blood have a long history together, and that's why taking blood tests as well can help in monitoring the health and kidneys by measuring the urea filtration or the levels of creatine in the blood. Thank you guys, that's all for chapter 10. I hope you guys learned something. I definitely did. See you in chapter 11. You guys better like and subscribe. This sounds so stupid. Bro, it's literally a P-wheel. I lost where I was. Important argons. Argons. More permeable. Less permeable. Guys, I'm going into business. Why am I doing this? Baseball bat. The kidneys can get that. You need some water with it, or after it, or before it, or and absorb hydrogen. Oh snap! I need to refill my because I forgot the diagram. Diuresis. Diuresis. Am I saying that right? Secreted to promote red blood cells. Says. I don't know how to speak anymore. Yeah. Oh my god.